Shazri, founding member of MAPAN.
Malaysia is a country of immense natural beauty and resources, but with rapid economic growth and development, the need to protect our environment has become more urgent than ever. That's where MAPAN, the Malaysian Association of Public Advocacy for Nature, comes in. MAPAN is dedicated to helping MSMEs adopt environmental, social and governance or ESG practices through bottom-up training, capacity building and disclosure reporting. In addition, MAPAN is working to contribute towards the unification of ESG compliance mechanism, including the Malaysian ESG standard that benefits 97% of business establishments in Malaysia. Through private-public partnerships, MAPAN is helping to fast-track the embrace of ESG practices for smaller enterprises for a better, more suitable future for Malaysia. Join MAPAN in our mission to promote a sustainable future for Malaysia. Contact us today to find out how you can get involved.
Hello everyone, good evening and welcome to our MAPAN evening chat, 6th of March 2024. And today it will be about the logistics of plastic to fuel initiative. For those of you who have joined us before, welcome back. And for those of you who are joining us for the first time, welcome. A very warm welcome to everyone. And I have with me my co-moderator, Nancy. So I'll pass this over to you now.
Sure. Thank you, Sufini.
Yes.
So I'd like to introduce our guest of today. It's Mr. Faiz Sufi. So let me say a few words about him. Faiz, as he's fondly called, is an intergalactic dreamer and a serial entrepreneur. He's an accomplished logistics and transport professional. He's a chartered fellow at the Chartered Institutes of Logistics and Transport, council member of the Malaysian Federation Freight Forwarder, and acting president of Persatuan Penguasa Logistik Bumi Putera. Faiz is also a committee member. Sorry for my pronunciation. He's also a committee member at the International Malaysian Society of Maritime Law, IMSML. Faiz earned a bachelor's degree in business administration honors with a major in transport from UITM, followed by an executive postgrad diploma in port and logistics management from the University of Cambridge. In December 2016, Faiz founded Sufi Group of Companies, one of the few Bumiputera international freight forwarders in Malaysia. He co-founded Global Freight Network in 2021 with more than 30 country members all over the world. His core business is logistics, supply chain, and transport, business and logistics advisory and refurbished containers trading businesses. He is also offering lifestyle yacht services from Royal Selangor Yacht Club, Port Klang. When he's not leading businesses or advocating for his industry, Faiz is a devoted husband and dad who enjoys music from brands like Coldplay, Matchbox 20, Queen, and Ramones. He's a makeshift prop for SMS's Old Boys Rugby Club, an avid foodie, editorial board at his very own ThinkWorks newsletter, and self acclaimed movie critic, nature lover, and occasional contributors to Tiger's Super Sports e magazines. Though he hasn't been running and hiking as much he'd like to do, but Faiz believes the world is his oyster and enjoys tackling whatever comes his way, including his beloved Manchester United's somewhat mediocre performance these last decade or so. So this is about Faiz. Let's welcome him on board.
Yeah. Yeah, Nancy, sorry if I would like to interrupt a bit. I think participants would like to know where you are joining us from.
I'm actually at home. Yeah, I'm at home. It looked blank at the back, but all the havoc is in front of me, so that you cannot see. I'm located in Setia Alam,
Uh-huh.
Selangor, yeah.
Yeah. And Nancy?
Yeah. I'm
Nancy,
from
you're not
India.
in Malaysia? You're not
No,
in Malaysia. Yeah.
India. So, being a member of Malaysian policy advocacy is, it also offers members from different countries and different talents to join this organization. So I'm happy to be here, and almost all names are similar to Indian names, so I'm kind of familiar.
All right. So okay then I guess Faiz, you can take it away then.
Thank you very much, Sufini. Thank you very much, Nancy, for that extended introduction. Yeah, I thought you're gonna refine that shorter, but you have read the whole thing. Oh, just FYI, Nancy, my name is pronounced Far East, from the
Far
Far
East.
East, from the Far East.
Okay,
Yeah,
got it.
as simple as that. Yeah. So so let's start. Can we have the slide on now? Okay, so this is my introduction slide. It's plastic to fuel technology. Okay, I've mentioned down there powered by RZG and syngas. So just to qualify myself, Sufi Group involvement in this is purely for the logistic and supply chain part, because the technology belongs to RZ Gemilang, RZG, and also syngas. Yeah, so those are the guys behind the technology. But I'm definitely going to connect you guys with them. Okay, can we move with the first slide? Okay, the agenda today is going to cover these three areas. Solving the global plastic pollution. Yeah, we need to really understand the big picture, how they are how they are founded, how they are manufactured, and I will share with you some latest statistics on plastic, on recycling, on many things to do with this global pollution. And then I'm going to go direct to a solution where we can turn plastic to fuel. Yeah. So this is quite interesting, where there's actually a technology which is already there, whether we want to use it or not, to actually solve the problem once and for all, or at least manage the excess waste, yeah, from plastic all over the world. And immediately after that, I'm going to touch a bit about circular economy. How does the plastic industry can actually be reduced and be reused again for future product and future use. Yeah, so that's going to be the thing that I'm going to cover for today. So moving on to the next slide. Solving global pollution, and the struggle is real. Yeah. Okay, next. So in 2021, the world produces about 400 million tons of plastic. That's only in 2021, yeah. So and that for 2021, enough plastic to cover the entire skyscraper in New York City. That's how big it is, yeah. And you see this the chart next to this. If we do not do anything, nothing be done. Looking at the trajectory, by 2050, we're going to hit 1 billion ton, more than 1 billion ton of plastic production per year. Yeah, so that's going to be catastrophic. Yeah, catastrophic. Moving on to the next slide. Plastic was founded in the year 1965, and the world uses about close to 500 billion plastic bags per day. And we manufacture about 1 million plastic bags every minute. That's how much it is being manufactured, let alone being used, being thrown. Yeah. As plastic is man-made, it is not biodegradable. I think most of you know about this. Yeah. And most of you would want to share as well. There are now biodegradable plastics. If you go to certain retail store, they have a biodegradable plastic, but they're not much yet. So the majority is still the non-biodegradable plastic. Yeah. Moving on to the next slide.
We seem to have lost him.
I'm sorry, I I lost connection about 30 seconds there. So plastic come from the Greek word plastikos, meaning easy to move. Thanks to the American inventor Leo Baekeland, we have all these uh, solution to container and carrying stuff. But and also thank you because of the problem, the waste problem. Like I mentioned just now, from the last slide, plastic is man-made and it's not biodegradable. Okay, let me show you from the slide. Throughout in 1955 to 2021, there are about 9.2 billion plastic already out there, still there. So out of that, about 1 billion are incinerated, 5.3 billion are discarded. So these are the waste part, about 5.3 billion, and about 2.9 billion still in use. This is still in use. Hopefully, they will reuse it again. And about only 20% of that is recycled. If you can see, that's about only 700 million tons. Moving on to the next slide. It is estimated that it will take between 450 to 1,000 years for plastic to dissolve. I mean, definitely not within our lifetime. So if you remember I mentioned just now that 5.3 billion ton that's been discarded, they're still there. They're still there in the environment somewhere. And how do we get rid of something virtually indestructible? They are just so cheap to be thrown out. So is recycle really the solution? I mean, you know there's campaigns all over the world that because people are expected to recycle this plastic. So let's see how much that we recycle. In the next slide, you can see there are only about 20% of plastic being recycled. Out of that, 9.7 billion tons of plastic, only 20% are recycled. And the rest are in incinerators and landfill, or just simply waste. and also there are about 12 million tons of plastic are dumped into the sea every year. And this is, I'm talking about every year, the 12 million tons of plastic are coming into the sea. And this plastic grouped together became an island. So in the next slide, you can see they call it the ocean garbage patch.
Faiz, I just wanted to sort of like add in, like when you mentioned biodegradable plastic bags, I think a lot of us would think that they being biodegradable, they would biodegrade when they go into the landfills, but they actually take some years to actually for that to happen, right? And it's still not like it's gonna like disappear within a day or two. It still takes a number of years.
So even the new technology that built biodegradable plastic bags, it may not go to 450 years to 1,000 years. Probably they can be dissolved within a decade or so. So that is still a problem. The problem is still not solved. So just for an example about this ocean garbage patch, there's one huge one in the Pacific that is twice the size of Texas. I mean, just imagine the sheer size of it. And I think most of us have seen in YouTube or Instagram stories, they are killing about 100,000 marine animals and 1 million seabirds. So what happened was some of these plastic stuck in the neck of seals or birds. So they basically stuck and choked to death. And some of these fish like sharks or even dolphin, when they were smaller, the plastic is stuck. When they are bigger, it stays there. So as it grow older, it will choke them to death. So that's actually happening right now. And and it's in the middle of the Pacific Ocean, yeah. And at this rate, by 2050, when we hit 1 billion ton production per year, the population of plastic will be more than the fish in the seven seas. Can you like take time to let that sink in?
We also have also seen a study where microplastics were stuck in fish, and people who were consuming it were being ill because of the consumption. So it could be a huge problem.
Thank you, Nancy. You are right. Microplastic are not just seen in fish, they're seen in people. So we actually unknowingly ate them. Yeah. So they are forever going to be there. Yeah. So we're not going to be older than 100 or 200 years. So it's going to be there until you're dead. Yeah. Thanks for that info, Nancy. So, okay, now that we know there's one huge ocean garbage patch in the Pacific Ocean twice as big as Texas, let's go to the next slide. Let me surprise you more. Apparently, there's more. There are about 1, 2, 3, 4, 5, 6 ocean garbage patch. So whatever I've mentioned in the last slide, times 6. Yeah. So UN just confirmed that it's at least 270,000 tons of plastic waste in our ocean. Yeah. So between 2050 to 2025, they proposed a 10-year operation to develop a system to vacuum up recycled ocean waste. So it's not that the world are not doing anything. They did. So there are some initiatives by UN, and a lot of companies are coming in. One of the biggest companies who actually come in and help is Maersk Line. If we go to the next slide, we can see Maersk Line dedicated few vessels like this. This is a convertible offshore supply vessel. So Maersk has already exited the oil and gas business. So some of these OSVs, they are using it to do cleanup. Yeah. So I went through earlier. They are focusing on the trans-Atlantic garbage patch, the one that twice the size of Texas, and their operation for per day they can only do probably close to 400 tons. Yeah. Per day. Yeah. So that's how much they can do it. So, but more and more people are coming in. Yeah. And help. So this ocean cleanup organization are not just at sea. They are also coming in at the river. So meaning that they're trying to manage the supplies of waste, plastic waste that coming from the river to the sea. Yeah. Sounds like Palestine now. Okay, moving on to the next slide. Coldplay played a big role. In fact, they have sponsored one of these in Malaysia right now. So this particular craft is actually in the Klang River, just about 15 kilometers from IM right now. So yes, there has been huge help because this ship has been making things work. Unfortunately, there are plastic coming in on a daily basis as well. So meaning that while Chris Martin from Coldplay trying to clean up our Klang River, our population here trying as much as we can to pollute it more. Yeah. So it helps, but the main root cause has not been resolved. Yeah. So let's see some stats at the next slide. Let's see who are the major pollutants by country. I don't want to mention the first and second. Let's go straight to Malaysia. We are actually third in the world. We are contributed about 73. This is 1,000 tons of ocean waste per year. So probably, unfortunately, we are number 3. Yeah. We are higher than China, which is the biggest, the company with the most population in the world. We are higher than Myanmar. We are higher than Bangladesh. I really don't see that happen, but it is, yeah. So this is the reality, yeah. And this is, the source is Visual Capitalist 2023, yeah. So you guys can Google it up. So the Statista has also issued the same stats. I saw it a few months ago, yeah. So this is legit. The problem is really with us. Yeah, we really need to find a solution to it. Okay, so we know who are the main country pollutant. Let's see who are the main pollutant by company. So let's go to the next slide. Coca-Cola, what 2.9 million ton per year. Yeah, so this is bad. This is bad. You can see who are the main polluters: Coca-Cola, Pepsi Cola, Nestle, Danone, P&G, Unilever, Colgate and Palmolive, and Mars. Yeah, so if you go by country, the company from country, I think US can top it off. Yeah, although they are not the main pollutant from the country list just now, but most of this company came from founded in US. Yeah, so this is the 2020 statistic, and this is the most recent that we can get. All right. Let's go to the next slide. Now, we want to find to offer a solution to this. Yeah. So clearly, we discussed that now. It's only about 20% of the total population of the plastic being recycled. Yeah? So there could be a solution to really solve this once and for all. So let's go and have a look at the next slide. So turning plastic to fuel, there are some stakeholders involved in this. One is the supplier. Supplier meaning that those who collect all the recycled plastic all over the world. And then the logistics, that's where I come in, where we move this plastic scrap to the incinerators or to the plastic the fuel factories. And the buyer will be there are a few initiatives right now. Before plastic to fuel, there are actually plastic to resin. Yeah. So what does plastic to resin mean? They actually reverse engineer, try to recycle this plastic waste to resin. Resin is actually the raw material to manufacture another plastic product. Yeah? So instead of they go to explore from the sea, from the petrochemical plants, so they just recycle whatever plastic that they have and go to resin to make new plastic. So meaning that the plastic is recycled to be used again. Yeah, and then the technology of plastic to fuel. Yeah, where they change it to fuel. Project location, syngas is currently one of the technology owner for this plastic to fuel technology. And of course, authorities, when I say authorities to move this, we need to get clearance from the local authority, and the license to run such factory or operation need to be issued by the local authority as well. And also the Ministry of Alam Sekitar, the Environment Ministry. Moving on to the next slide. So basically the process is quite simple and straightforward. Looking at this slide, so first we identify the supply, and we bring the supply to the incinerators or to the manufacturers, and then we manufacture. There's a lot of processes inside the manufacturer, and then the finished product is either the resin or in this case the diesel. The diesel. Let's go to the next slide. I'm sure some of you know there are types of plastic. Yeah, for plastic to resin, there are few type of plastic that they cannot recycle, which is PE, polyethylene, PVC, and other plastic including acrylic, polycarbonate, fibers, nylon, fiberglass. So that this is something that they cannot recycle. But the rest, the HDPE, they can. HDPE is part of the like milk jugs. So that is the favorite. You know, the plastic chemical drums, the blue ones. Yeah, shampoo, the bottle lids. Those are HDPEs. Yeah. LDPE is a low density polyethylene. Crushed bottles. Yeah, all the Coke bottles. Shopping bags. Sacks. Gunny sacks, the plastic gunny sacks, and wrappings. Yeah. PP, polypropylene, those come from furnitures, luggage, yeah, the consumer luggage, the plastic luggage, toys, um, external or internal interior of cars, yeah, those are PP. Well, the last one is PS. PS is polystyrene. I think you know what polystyrene is, yeah. That is for plastic resin. They cannot accept these three items, which is PE, PVC, and others. So the next slide shows us plastic to fuel. This is beautiful because for plastic to fuel, we can accept any type of plastic. Yeah? So they just need to re-engineer it, reverse engineering it back to the liquid function. Okay. Moving on to the next slide. Let me just run through the supply chain flow of this activity. Yeah? So the supplier can be all over the world. In fact, right now we are purchasing, we are arranging movement of cargo containers. Yeah, containers from, believe it or not, the first world country. Why? Most of these stores are coming from first world country because they have a very mature recycling program. Yeah? So immediately, my supplier in these countries can supply. They already distinguish or separated the high quality plastic like I mentioned just now, the PE, the PP, yeah, HDPE and things like that. Yeah. So most of the countries that we are bringing in right now are from Japan, which personally for me the best source, because usually from Japan they have separated everything nicely and they compress it into in bales, yeah, and they we really enjoy the product coming from Japan. Next will be Korea. We got good one from Australia as well. Now our team are also talking to North America. We have a good plastic source from Germany and UK as well. Yeah. So after the cargo arrives in Portland, we clear the cargo and we move it to storage. Yeah. For plastic to resin, there's another activity going on here. So for those plastic, remember some of the plastic material that cannot be recycled for plastic to resin, so it become garbage again. Yeah. So they discard it in Malaysia. So the idea of recycle, the good idea of recycle, they actually made a mess as well. So this is the part where I think the Ministry of the Environment are not happy. Yeah. So unlike PTF, plastic to fuel, we can like convert everything. So it's basically cleaner than plastic to resin. Yeah? So we move to the factory. At the factory, there are some more processes. Please move to the next slide. So
I have a question, Sophie. So some percent of it is recycled from the input you get, and then the other percent of it which cannot be recycled is disposed. Am I correct?
Come again, can you repeat that again?
So you get some percentage of plastic from different companies, and you recycle only what is good or what is crossing the threshold limit of recycling, and the other percentage which cannot be recycled is disposed. Am I correct?
That's right. That is for the plastic to resin. Like if you remember the few slides back, the types of plastic. If Raja, can you move back one more slide? One more slide. Okay, that's one. So you see, for plastic to resin, there are three types of plastic they just can't use. It will be discarded. Yeah, Nancy. So probably if you if you see, go back to the, if you remember the slide that shows that Malaysia is top 3, this could be a
Yes.
contributor because we imported all this plastic and it cannot be used. So now they are discarded in Malaysia. Yeah. So
Got it.
to me, this is wrong. To me, this is wrong. There need to be a process how to manage it, to incinerate it or to manage it. But for plastic to fuel, you go to the next slide, Raja. The next slide, please. Okay, before. Where is that?
I think it's the type. Yeah, this next.
The next one.
It's the next.
Yes. For plastic to fuel, we can absorb any type of plastic. So this has less waste to be discarded. Nancy, so I hope I answered your question, Nancy.
Yes, you definitely did. And do you think that there's any safe way of disposing it off without causing more emissions?
There need to be a process, and the only way other than landfill, unfortunately, is
Yes.
incinerators. We do not have incinerators in Malaysia yet. Yeah. So in a way, the Ministry of Environment are on the spot. Yeah, because they don't want to have that risk of having more plastic garbage. That's why there's a report coming in a few years back where they mentioned Malaysia become a what do you call a dump site for the world. Yeah.
Yeah.
It is true, but it's not entirely true. This is a good technology. It's a good what do you call income generating business. I will show you in the subsequent slides why it's good for business.
Yeah, actually, there is a company that makes mobile incinerators, but maybe we can take that into the next session, so that Pais can continue his presentation. Well, I was just wondering, when you get the supplies from let's say from Japan or from Germany, usually they're the ones who pay for the collectors, right, to take the waste. Is that correct?
Yes, that's right.
Right.
So usually the municipal council of each cities,
Yes.
they would pay to some vendors just to manage the waste. Yeah. So some are good quality plastic are they re-exported to country like Malaysia. Yeah. Okay. Can you move on to the supply chain flow, the operation within the this one. So there are some grinding operation where they shred this plastic to small pieces and they wash it, they compress it again. Is a DF machine, yeah, plastic to fuel machine. I will explain to you a little bit later on how does the processes within the PTF machine. Yeah. Moving on to the next slide, and then it churn out the final product. So it comes back to logistics. We will organize the packaging. We will organize the delivery to local buyers, yeah, and or traders. So that's where the logistics comes in from the first start and towards the end. So moving on to the next slide. So this is the rapid customization of the what you call plastic to fuel technology. So let me show you. Let me try to explain to you some basic what you call processes. They call this process pyrolysis. So first, the collection and sorting, the collect all the waste. The plastic waste is collected and sorted based on the types. Remember I mentioned to you the types of plastic and to ensure consistent feedstock to the pyrolysis process. And then we do a little bit of shredding. You saw in the last two slides. They sorted the plastic, shredded it to smaller pieces, increasing the surface area for the subsequent processing. At the same time, they do the feedstock preparation. The shredded plastic is prepared for the pyrolysis reactor. And the pyrolysis reactor, the plastic is heated in the absence of oxygen, at high temperature up to 300 to 900 degrees Celsius. And this process breaks down the chain of polymers into smaller hydrocarbon, gas, and char. For the gas, they have a mixture of gas and liquid hydrocarbons and solid residue. The gas usually pass through the condenser and convert it into liquid fuel. The condensation. So the condenser cools down the gas, causing it to vapor to condense it into liquid fuel. So it becomes fuel. Immediately become fuel. And then they did a little bit of fractional distillation as well. The liquid fuel obtained from the condensation goes through a distillation process, separate different hydrocarbon based on their boiling point. So they can go to types of different product of fuel. And the final product, liquid fuel, gases, and residue, known as char or coke. So for storage and distribution, the resulting fuel, often referred as pyrolysis oil or synthetic fuel, can be stored and distributed for various applications such as heating or powering engines. And we send the final product to what we call trading companies. So they came back. Our end product is actually Euro 3 level of fuel. So it's quite good. So we have demand on that. So moving on to the next slide. We spoke to Vitol, second biggest oil trader in the world. They are based in southern Johor and Singapore. So they have approved our sample. They also have indicated wanting to take this up if we can scale the production. So the one that you saw just now that's the prototype, only a prototype. So every day we're not doing this, we're losing a potential revenue. So there's a big push to scale this for bigger manufacturing or plant. So look, moving forward to the next slide. So we are now at the final chapter. Let's talk about the circular economy, and if you remember the session that we had with Ben, the founder of MAPAN, the current chairman of MAPAN, he mentioned that ESG shouldn't be costly. It must be generating income for everybody. So I think this is a good example coming up from what Ben has mentioned. Let me show you in the next slide.
Mr. Sufi, before you proceed
right
to
now,
the next slide,
the production capacity of that small prototype is about 12,000 tons per annum. So if we scale it, we can produce more and more, and we can use more plastic from all those 6 garbage patches throughout the world, to generate back fuel to be reused in the market. Next slide. The process of PTF is about 50% carbon saving compared to the natural way of absorbing the fuel from the sea, from the platforms. So 50% carbon saving. The next slide, it shows is very low operating cost. I did some Googling a few days ago, and I found out that the cost of doing PTF is actually about 1/5 of the cost of exploration oil in the 7 seas. So it's about 1/5 just doing that. The only challenge is to get all those plastic from waste. The biggest challenge would be from the landfill, because it's already it's not separated. You really need to move it one by one. Yeah, so it's quite a challenge. Could be costly too. Yeah, but still it is 1/5 of the operating cost of the big oilers. Yeah, exploring the seven seas. Moving on to the next slide. This is again based on the small prototype PTF machine. So the IRR is about 13.78%. Yeah, it's good. So if you scale it, you can move it up to 50 to 60. Yeah. So just some numbers for you. Moving on, the project NPV is about 20.8 million in 10 years. Again, this is for that small, what we call prototype. So if you scale it, this 20 million is nothing. It can be in the billions of ringgit or dollar. Yeah. Moving on on the next slide, the CAGR for plastic demand is about 6% every year, and this is just Malaysia. I've also checked that for global demand for plastic is about between 7.5 to 8%. Yeah, so we are on the right track. Yeah, so that's demand for this, especially for resin. Yeah, plastic to resin. Moving on, Malaysia diesel consumption about 7.6 billion liters in 2023. This is a drop of 28% in 2019 to 17% in 2023. The reason of this drop because some of our trucks are going for NGV or biofuel. Yeah? So there is actually a slight drop in the demand. But then again, if we can, this is the immediate demand of diesel if you convert the plastic to fuel. Yeah? So you just imagine you have a captive market of 7.6 billion. And if not on for Malaysian market only, we can go regional. If not regional, we can go international. Yeah. So I would invite investors, especially the big oilers, to come to look at this technology. Yeah. So we can start to have to have a circular economy on plastic. Yeah. Moving on, a snapshot of Malaysian plastic industry. They employ about 81,500 people. Yeah, in Malaysia alone, and the size of the industry about 30.98 billion. It's close to 31 billion ringgit. Yeah, so we know for sure the business of recycling plastic is huge. So we should be capitalizing on it. Yeah? Probably this can be captured under NETR. Yeah. Probably in the next SLU, sesi libat urus with the government, somebody can share this info officially with the ministry, and that is about 47% export. Yeah, so it's good. It's good for business. We have enough huge market, and this is just Malaysia. Yeah? So we are finishing on the last slide. This is a bit what us, Sufi Group. Nancy mentioned a bit here and there about Sufi Group. I'm just going to say that we are one of the leading advisory for logistic ports and transport in Malaysia. We do some trading. Most trading are basically empty containers, and of course we are also full-fledged freight forwarders. Yeah, international freight forwarders. And going to the last slide. Thank you very much for listening to us, and I welcome question if you have anything. Thank you.
Yeah, we can address the ones that we have in the chat. Yeah, I think the first one is from.
Thank you, Dr. Tan.
Yeah, you can see the question there, Faiz. Yeah, it's about like the process of ocean trading. Yeah.
The microplastic. Okay, if during the shredding, yeah, there are some exposure there. I must agree with you. But during the FTF, PTF process, plastic to fuel process, even the vapor are being recaptured. Yeah, if you remember when I mentioned just now, even the vapor are captured to be recycled to become the fuel.
Yeah, it
And,
is.
This technology is not perfect yet. Yeah. Syngas is actually operating in Terengganu right now. Yeah. So I would love to bring you guys, if anybody want to have a look at the small prototype. The name of the owner is IR Adan. So he's the professor behind this. Le professor.
That's nice. So, do we have emissions in this process?
I can't hear you, Nancy. Are you saying
Do
something?
we have emissions in this process?
Nope.
um,
For me.
maybe you need to type,
You can see. Okay.
yeah, type the question in
There has been some
onto the chat.
technical. I don't seem to be getting what Nancy is trying to say. Probably you can text me in the WhatsApp group.
Okay. What about, why is this like, if
Oh,
if
you
this is
asked
like,
about do we have emission in the process? Yeah, they have some emission, but it is captured back to the process to the PTF machine. All have been recaptured back.
can you hear me, Faiz? You can't.
I still cannot hear you. I don't know why. Earlier, I totally can hear you.
Let me see.
You're not on mute, but I just cannot hear you.
Let me see if I can do this. Okay. It's really hard.
There's a question here. Will it make other materials instead of fuel? Yeah. We can recycle it to resin. Resin is actually a raw material to manufacture plastic. So that's one process. They reverse engineer it to resin, so they can reuse. So we don't need to get the resin from petrochemical plant. Yeah. So it is cheaper. Like I mentioned just now, the cost of production is cheaper. The hydrocarbon is cheaper. It's lower in terms of carbon saving and low operating cost.
I have a question, Mr. Sufi. Can you hear me?
Okay, thank you, Sufi. Yeah, if this tech is good, why hasn't the industry taken off yet? Yeah. So it's the same thing. We know we can
No,
generate
that's
electricity from solar. And we are actually in the equator, yeah. So we have the best sun, but why don't we do solar? Yeah. And if I may add a little bit, we all know there are fully electric vehicles right now, yeah, and we just need to charge it, and if we control the grid, we can generate electricity from solar, store the electricity, and charge the likes of Tesla or BYDs, yeah, in the market. So basically, we really have a clean car technology there, yeah. But I don't know why the price of the electric cars is as much as a Mercedes-Benz. So I really don't get it. It should be a car for masses, yeah. But probably we want to protect certain industry. I don't know. It's a political will, yeah. It's a political will. How does this process contributed to decarbonization? Okay. Well, we are trying to solve one problem, definitely. Yeah. The problem is plastic. So the whole idea of the presentation and slides is to show that, hey, we do not have to not use plastic straw anymore. Yeah. Every time I go to tea leaf, I have a problem with this papered straws. It it become soil and when wet, yeah, and it dia macam lembik. So I miss my plastic straws, yeah. So with this technology, we can continue to use that because we know we can always what do you call, recycle them and generate back to resin or back to fuel. Let me see. Any more questions, guys?
I think Sufini has a question.
Already
I
posted.
don't know why I still can't.
Already posted. I've already posted that one. Yeah. Yeah, we're so worried about it. Yeah, I mean, it is a concern that we are, like ingesting microplastic from the ocean, through the fish or the, but, and yet we have people making ice cream from plastic. So I don't understand why, why that is happening. Anyway, so Faiz still cannot hear us, so it's kind of hard to chat here.
I
I
pass the floor back to Sufini and Nancy.
Can you hear us now?
There's a question here. Any health risk to the process? That I wouldn't be able to answer that honestly, because that has not been finalized. The technology is still at an infancy stage. So right now the focus are actually on output. From the last trip to Terengganu, I was briefed by IR Adan that they reuse all the vapors or the odors back to there's no odors actually, back to the PTF. Yeah. So I think in a way it's quite safe, only that there's no particular research done on it yet. So I wouldn't be able to share more on that. I totally agree on microplastic is everywhere. This might not solve 100% of the problem, but it can solve most of the problem at least. I'll leave it to you, ladies.
It's 9:23. I mean, time moved really quickly, and it was like a very interesting presentation from Faiz. I have to say, right, Nancy?
Yes.
I think you have one or two more questions, or you have covered.
So I have a question. Who exactly buys?
Okay. As a summary, thank you, Raja. I saw your text there. As a summary, this is the technology is already there. Yeah. When I Google it, it's not just in Malaysia. I found the same a similar technology in Korea, in Japan, and in India. The logic of the process is the same, where the pyrolysis process, where they heat up all this product and they reverse back to the original form. Yeah. So it's like a reverse engineering kind of thing. Yeah. And we can solve our plastic waste problem, or in the 7 Seas, bring it here to be re-engineered back to their original form. Yeah. So there's a solution. At the end of the day, is the what you call the political will, or hopefully some of the big oilers or big corporation taking over this, and scale it up so that we can really enjoy the technology and solve the problem of plastic all over the world. Thank you.
One more question there. One more question, Faiz, from Nancy.
Nancy, you asked here who buys this recycled fuel. Okay, Remember in the slide, there's one company called Vitol. Vitol is one of the the second biggest oil trader in the world. So we have spoken to them. They've seen our sample, and they're the one who did the study and came up with the Euro 3 status of our fuel. Yeah? So they want it, but we don't have the volume because it's too small.
Right. Okay. Thank you, Faiz. Thank you for that presentation. I mean, it was very, very interesting, and I think to all the participants who have joined, and I think you also found that very interesting. And thank you for
Thank
the
you very much.
questions. Yeah.
I hand this floor back to Nancy and Sophie.
Right. Okay. Okay. Then I've said what I need to say. Then, and Nancy, probably you would like to close this.
Sure. So I think it was a wonderful presentation, especially in the age of circular economy. We have people like Mr. Sufi carrying out the business of circular economy and then recycling plastics into fuel. I think it's a wonderful topic, especially it being the plastic waste. Instead of throwing it into the ocean, we are putting it in our vehicles. We put it into generators. I think it's a wonderful presentation. I've really enjoyed it, and also I hope our viewers have enjoyed it as well. Thank you very much, Mr. Sufi and Sufini.
All right, and we will be announcing our next session. I mean, very soon. It should be airing on the 16th of March, but it will be during the day. So wait for the announcement. And so once again, thank you very much. And we wish you a very good evening if you're in Malaysia, and if you join us from outside of Malaysia, maybe, have a good day or have a good evening as well. And we'll see you again. Bye.
Hi, I'm Shazri, founding member of MAPAN.
Malaysia is a country of immense natural beauty and resources, but with rapid economic growth and development, the need to protect our environment has become more urgent than ever. That's where MAPAN, the Malaysian Association of Public Advocacy for Nature, comes in. MAPAN is dedicated to helping MSMEs adopt environmental, social and governance or ESG practices through bottom-up training, capacity building and disclosure reporting. In addition, MAPAN is working to contribute towards the unification of ESG compliance mechanism, including a Malaysian ESG standard that benefits 97% of business establishments in Malaysia. Through private-public partnerships, MAPAN is helping to fast-track the embrace of ESG practices for smaller enterprises for a better, more suitable future for Malaysia. Join MAPAN in our mission to promote a sustainable future for Malaysia. Contact us today to find out how you can get involved.